हाँ हाँ राकेश तो दहा मारून हाँ ना हाँ Hello friends. Today we are discussing the serial communication protocols in the subject of the microprocessor in this lecture series. Serial buses use UART uses a serial buses for sending and debugging the messages to your development host. ISQ or IC serial buses for the communication with the sensor, and SPI serial buses for the communication with a Bluetooth, a low radio energy radios. These are the three serial buses in this lecture series. We are discussing, or we are uh, detailed viewing of all these three serial buses. The UART, asynchronous synchronous transmission, that is a serial buses for sending and debugging the messages, that is the I2C serial buses for the communication with the sensor, that is an exemplary the accelerometer. The SPI serial buses for communicating with the Bluetooth low energy radio. Parallel buses where the serial buses, the parallel communication is done at the same time. All the 8 bits are transmitted from source to the destination, okay, or in from the input to the output. But in case of the serial communication, a bit by bit communication is transmitted over a clock signals as shown in a figure. If a parallel buses are more reliable, or we can say faster than a serial, okay, but a parallel are a slower and a serial are a faster communications are there. In the parallel communication, all the bits are sent at the same time for the from the transmitter to the receiver. Or in case of the serial communication, uh, from a sender to the receiver, a bit by bit transmission is done over a synchronized clock signals. Whereas in case of a parallel bus transmission, a clock signal is also there, but a serial bus interface motivation to the center without using a lot of the IO lines. It doesn't use a lot of the IO lines. IO lines requires the IO pads, which cost and a size. IO lines require the PCB area, which cost a much more dollars and a size. It connects a different system together without using a lot of IO lines. A serial bus interface communication. Why the serial bus communication is started? Because IO lines is required IO pad with the load with the cost and a size. Without using the lot of the IO lines, it uses a transmission of the bus, or a serial communication is done without connecting a different systems together. A two embedded system can be connected together. That means it can able to connect a different system at the same time. A desktop and embedded system can be connected. Connecting different chips together in the same embedded system, that it can the MCU microprocessor controller unit to the peripheral and microcontroller controller unit to the microcontroller unit. That means a communication between the microcontroller to the microcontroller, or micro or a microcontroller to the peripheral is possible in case of the serial bus system. So here it supports from microcontroller to the microcontroller communication, also from microcontroller to the peripheral communications. It often at a relatively low cost data rate, but sometimes at the higher data rates. So what are our options? A universal synchronous asynchronous receiver transmitters. It is an USART, that is USART, universal synchronous asynchronous receiver and a transmitter, which is also known as a USART, U start. So UART, that is a universal asynchronous receiver and a transmitter. Hardware that translates between a parallel and a serial form, that is an UART. This is commonly used in a conjunction with the communication standards such as the EIA RS-232, RS-422 and RS-485. The parallel and a serial communication is a here UART, that is a universal asynchronous receiver and a transmitter. It supports for the EIA RS-232, RS-422 and RS-485 ports. A protocol, UART protocol, each character is sent as a logic low start bit. It sends as a logic low start bit, a configurable number of data bits, that is usually 7, 8, sometimes the 5 data bits. An optional priority bit, a priority bit is there for checking of the priority, whether a data is having a higher priority or a lower priority. But here the priority bit is an optional, one or more logic high stop bit. When you are a logic low, it is having a start bit which is a logic low and a stop bit which is a logic high. Start bit indicates that the data is started and the stop bit indicates the end of the data. With this particular a bit timing at a baud rate is there. UART sends and receive a ASCII letter W. How a ASCII letter W is sent? The ASCII value of the ASCII W is 1010111. So how this data is transmitted from a sender to the receivers? The line is ideal. The start bit, which is a low. Oh, now a 3 bits are started 111 and a low again signal is there. When a high one is sent, a 0 and 1 and 0. Last 0 which is an priority bit, and again okay. So and a stop bit which is an higher at the line becomes an ideal after transmitting the uh, letter W, ASCII letter W. So how can you understand how a data is transmitted from source to the destination by using a UART? Okay, this is how a data is transmitted. Thank you friends for watching the video.